Welcome, ma'am.
Yes, I shared my slide, but still,
Yeah,
is it visible to everyone?
no, ma'am.
Uh,
Share,
I, I'm sharing PDF. I'm not
share.
sharing.
Yes, share.
Yes, I have shared it, but uh,
Windows. In your screen, there is a two option. Windows, you will share. Screen and Windows. Windows.
that's fine. Excel. I browse my computer, so screen okay. And select entire screen. Okay, fine.
mm,
So now is it
Screen
visible?
is screen is visible. Your PDF file, that is
Uh, so,
your screen is visible.
that's fine. Then once I okay, wait. So since I shared my whole screen, now it should be visible to everyone. Is it visible?
Yes, ma'am. Now it is visible.
Okay, so I'll be talking on
Okay.
machine learning fundamentals for healthcare application. I guess throughout the week, everyone would have heard of this application. So I'll be talking about fundamental concepts. I'll apply those concepts. I'll show the actual application of machine learning on few problems as a case study. But before proceeding with those applications, first of all, we'll try to understand what machine learning is and why and where we can use machine learning in healthcare. So to start with, I'll be starting with what is machine learning, why healthcare needs machine learning, and which in turn is actually the requirement of the growing volume of data that has been generated. So let's proceed with uh, the definition of machine learning. I know everyone might be aware of what is machine learning. Uh, I'm keeping my video on, and this would be a difficult task. So can I continue with the,
No, no problem, ma'am. If you are no problem.
okay, so let's understand what is machine learning. I know everyone might be aware of what is machine learning, but still, since throughout the sessions, what I have seen is machine learning has not been covered as the separate topic in the complete FDP duration. So introducing it is something which is the utmost requirement. So we all know machine learning is a subset of AI, right? So AI is a bigger uh, chunk, and within it comes machine learning. Now, what machine learning does? Okay, it's confined with, or it specifically focuses on developing algorithms that enables system to learn from data and gradually improving the performance uh, based on the data, like based on the feedback that has been provided to the learning environment. It improves. It's something like child learning step by step. So we know that in the from the age of 0 to 5, a child learns maximum, like its capability to acquire knowledge is maximum. Okay, so whatever you feed to them, they'll grab very easily. So the same philosophy is applied to a machine learning concept. See, your machine computer, if it is not fed with some data, it will not acquire any knowledge. So unless and until you don't feed a data, it will not learn. It's a similar philosophy of child. Unless and until you not teach the child that this is wrong or this is right, they'll not learn those things. So, on similar fashion, machine learning expects you to provide some concrete, sufficient data so as it can learn from those data and make predictions or give necessary outcomes based on what you expect. Okay, so here we don't need to have an explicit programming because it's actually truly speaking, this statement is uh, not completely true because you need to program to some extent by making use of libraries, but we don't need to deal into the intricacies as of now. We are not dealing because people are actual real researchers are working on developing the algorithms which you can developing the models which you are using for some applications. So you we have a rich set of libraries available in Python, wherein all these models have been made available to you uh, in a click. Okay, so you can just like, let's say, suppose if I want to use SVM, I just need to write SVM and I'll be able to get all the functionalities related to implementation of SVM. So you don't need to go into intricacies of how the implementation of SVM is done or how CNN is being implemented in your machine. You can straight away use those implementations which are the library functions in your code and apply it for some problem of your choice. Okay, so explicit programming, the meaning of without requiring explicit programming means that you don't need to write explicit code for all this uh, internet components that you have been using, those libraries that you have been using. But as such, it's if you want, you can always write it. So broadly speaking, uh, machine learning algorithms has been broadly categorized into four categories. One is supervised learning, and no doubt it's very new, but still, because to start with, I'm covering it. Then we'll proceed with the detailed algorithms that can be used for various categories. So, supervised learning, unsupervised learning, reinforcement learning, and deep learning are the four broad categories which we can think. At times, you may think that there is no need to have deep learning as a separate categorization, because deep learning in turn involves you can use a combination of, you can either use supervised or you can use an unsupervised, or you can use a hybrid approach of supervised and unsupervised within deep learning model for implementation purpose. Okay. So however, since we can use the combination of this has been separately categorized over here. So there are several different applications of each of these domain, and uh, before proceeding to those applications, we need to know what is this domain all about. So what supervised learning means. So as the name indicates, supervised. So there is some supervisor who is observing you and who is guiding you towards achieving a goal. So in case of supervised learning, we expect that some kind of data is labeled data is being provided, which in turn is nothing but a supervision that has been provided. So if you are saying that there is a tumor existing in some image, so if you have some brain MRI available with you, and if you want to, if you have a label assigned to it that there is a tumor existing it, then in that case, this existence of a tumor is a label that has been assigned to it, whether a tumor exists or tumor does not exist. If I'm giving a label of this kind to a data, it means that I'm having a labeled data, right? So if I'm dealing with using, if my machine is learning through such labeled data, then in that case I'm making use of a supervised learning algorithm in it. Okay, so there are several applications that for which the data is also, there are several sources of data. Again, as of now, there are several sources of data that are available related to healthcare and various other domains as well. Kaggle is one of the well-known source of data for uh, this category. So let's say, suppose if I want to predict diabetes based on patient history, then in that case you need to have data corresponding to the patients, whether you need historical data about the patient and whether the patient is suffering from diabetes or not suffering from diabetes based on the historical data. So if I have this data, it means that I'm having a label data, and based on those label data, if I give some test data and if I want to make a prediction whether this person is suffering from diabetes or not, then through the learning that has been acquired from the label data, one can make a decision regarding the possibility of having a diabetes for
हैं?
a yes.
नॉन ट्रेनिंग का डाटा बना रहे हैं
Sorry.
इन लोगों के सर्टिफिकेट मेरे पास आ चुके हैं
Hello.
इसके नहीं है शॉर्टली
I cannot hear.
मैम को दिखाते हैं जाके देखिए रोज कहते हैं कि बच्चे नहीं आते बच्चे नहीं आते हैं
कौन
तीन चार बच्चे आ रहे हैं बाकी सब बच्चे जॉब है उनका लेटर ऑफर लेटर ये
Yes, ma'am. Continue. I have muted them.
अंकुर तो नहीं डिस्क्राइब कागज का पेटी से बनना
Yes, ma'am. Continue. Ma'am.
You are not audible.
Okay. Ma'am, unmute your mic.
Okay, is that okay?
Yes. Okay, ma'am. PPT. Yes.
So the
Yes.
other category is unsupervised learning, wherein you don't have label data available with you, and you want to extract some hidden patterns out of those data. Okay, so if your task is regarding categorizing few like categorization related tasks, then in that case one can think of using an unsupervised learning approach, like clustering similar group of patients is an example which illustrates the use of unsupervised learning. Apart from supervised and unsupervised learning, there exists reinforcement learning as well, wherein the learning is through trial and error, and the objective is to maximize the outcome. Here, basically, the concept of learning from the environment and a use of agent driven approach is being done within it. Okay, so you basically reinforce, like a child, once he starts walking, he may fail, he may fall down, but gradually when he learns that if I walk in this fashion I will fall, then in that case he'll not make the same mistake. So he learned from the environment that performing this, or if someone is guiding them, and that guidance is also through the environment. Okay, if a mother is guiding a child that don't do like this, else you'll fall down, then in that case the child will not do, because he or she learned from someone from the environment that doing this thing may lead to some kind of harm to him or her. So, learning through an environment and taking actions corresponding to it and improving upon the performance is what is reinforcement learning. Okay, so you reinforce someone to do something based on those learning. And the last one is the deep learning, which basically is making use of complex networks like neural networks for various complex tasks. The deep learning is basically concerned with the number of layers that you are introducing. So earlier, when neural networks were being used, At that time, only one or two or three, max three layers were being used as an intermediate layer between the input and the output for performing some kind of task, and which could be manually trained and supplemented with data so as it can improve. But networks are really deep, wherein manual intervention will not be possible for tweaking or changing the values at each and every node that exists between the input and the output. But it involves several layers within it. Okay. So again, there are several examples of applications of using deep learning, like if you want to use it for tumor detection in brain, you can make use of deep learning networks within it. And uh, uh, you may make use of it even for diabetes detection or various, if it is a case that the quantum of data, the thing is, when one should make use of these deep network when the quantum of data is very large. At that time, deep network are expected to give good performance, and it is preferable to use this network, as you can make use of some naive learning techniques which can even perform better in those cases, when the data is less. Okay. So now, why one should offer using ML in healthcare? Now, we are very well aware of the fact that the amount of data in all domain, it's not just healthcare, but in all domain, you'll find that the day to day, the amount of data that has been generated uh, by various sources is increasing by an enormous amount. Now, the same is the scenario with healthcare. So this is one projected data which is almost used by most of the researchers, but it has not been authenticated by anyone. But still, researchers are actually using this amount of doubling of data in every 73 days. Okay. This is basically amalgamation of all the kind of data. It's not just one data, but it's an amalgamation of data generated from various kinds of sources, which can include an EHR data, imaging data, genomics data, or IoT based data using various variables that has been used by several end users. So, but like if it is a case that the healthcare data is uh, expanding by such a huge amount, then analyzing those data with such a scale is very difficult for a human expert to carry out in a short span. Okay, so a human expert can analyze this scale of data which has been expanded. So we need some faster mechanism through which we can analyze this data, make a diagnosis based on the data, so that treatment can be carried out on timely basis. Let's say, suppose if it is expected that a person is to be treated in a person should be immediately treated in 5 days. Okay. It is expected that there is a span of 5 days. If some kind of treatment is expected and if it is not done before 5 days, then it's likely that the repercussions may be very high. Now, if it is a case that the process of us allocating it to some doctor, and then the diagnosis, if it has been done by some doctor, is going to take huge amount of time to first analyze it and then make an interpretation, then in that case it's likely that the number of days that would have crossed maybe more than 5. Okay. And it may be a case that you may not be in a position to treat the patient. But if you use a learning based approach, if some doctor is also making use of such guided support of machine learning for analysis purpose, then in that case they can reduce the time of interpretation, and which in turn allows us to have a timely treatment to the um, patient. Okay, so the faster diagnosis in turn can lead to timely treatment, and which in turn can also save the life of a patient. Uh, Apart from this, like, see, we as a human being are likely to make mistakes. Doctors, we say they are God, but everyone can make mistake, even doctor can make mistake. Okay, so it's likely that a person, if he's suffering from diabetes, but a doctor is, because of some reason he said that you're not suffering from diabetes, or there's a patient is suffering from cancer and a doctor uh, was not in a position to interpret the MRI image properly, and he said that you are not suffering from cancer. So if such things are left undetected, no doubt diabetes may have repercussion uh, later on, but cancer are something which has a repercussion in a short span. If it is not treated early, then the implications can be very high. So if there are critical conditions, critical diseases which has to be taken care of as early as possible, then in that case, an error, human error, if it occurs in such cases, may lead to life threatening condition for a patient. So in such cases, we can take a support of AML to improve the efficiency of such processes. So these are few statistics that I have received from various sources. Again, these are not my, but I have collected from various sources, uh, which basically states. So the 73 days doubling is basically an accumulation of all this kind of data that has been projected over here. So like a genomic data, it actually doubles every 7 months, and it is expected to reach exabyte scale by 2025. No doubt we are in 2025, and uh, uh, it is almost uh, reaching exascale. It has reached exascale byte as of now. Okay? Uh, Wearable devices, like, I hope you might be aware of using various kind of wearable device, like you are using a smartwatch. It's also generating, like, you can make use of it for generating ECG and various other health related parameters, on the basis of which several decisions can be taken. Apart from that, there is, like, you may have some variable device in the form of high pressure measurement or diabetes measurement. So all these devices are generating some data. Okay, and this market, the wearable tech market, uh, 2024, the amount, the it was around 84.19 billion, and is expected to hit 186 billion in 2030. So the CAGR rise is 13.6% in wearable devices. On similar line, if we talk of medical imaging, EHR, and research data set, this is actually authentic data from MICAI journals, like 2011 to 2018 papers, basically states quantum of median data set size growing from 3 to 10 times. And again, that also depends on the modality of the data, like whether it's MRI or CT scan or other fMRI and so on. But the geometric mean data set growth per year for MRI, CT scan, and fMRI is expected to be 21%, 24%, 31%, respectively. The other domain is big data, which is projected to be 540 billion US dollar in 2035. Uh, in 2024, the quantum was 78 billion, but you can see the exponential growth in the healthcare market of big data. So a CAGR rise of 19.2% for this period is what is expected in big data in healthcare. So overall, the whole statistics is basically projecting that the amount of healthcare data that will be generated is enormous, and you will require like either you will require more number of professionals, medical professionals, who could perceive this data and make interpretation of, from it, or you use some learning algorithms which can learn from this data and make interpretations which can be beneficial for the doctors. Now, what is the advantage of using ML in healthcare? We can basically do early detection and diagnosis. Like as I said, that we expect that the outcome of the disease detection should come within 5 days, and unless and until if it is a case that we are relying on some manual approach, if it's taking more amount of time, and if you're using a learning based approach, and if it is giving a response in a day or in within a half an hour, that would be much more preferable. So diseases like cancer, Alzheimer, heart conditions, if they are treated earlier, they can actually benefit patients a lot. If we proceed with using a traditional method, it may be a case at times it may stay undetected, because like Alzheimer is something which generally people don't bother even in the early stage. They may not notice the symptoms of Alzheimer within them unless and until it is not prominent in their like day-to-day activities. If someone is not encountering any kind of problems in their day-to-day activity, they may not feel the presence of Alzheimer in their as a disease in the body. Okay, so these diseases are crucial if it has been diagnosed in early stage, and if it is diagnosed, there is a scope for performing medicative treatments for them. Okay, other area in which we can think of using health this MLS personalized medicine. Okay, so we can work on identifying treatment plans for patients based on their genetics, their lifestyle, the medical history. Taking those factors into consideration, they can basically you can give spatial treatment for each and every individual. Okay, so one can use ML for this personalized medicine, or like I can say an example, like if we are retaining an historical data of patient, then in that case it in turn can also help a lot while when a patient is treated recently. So I have a live example regarding it, why historical data is of relevance to us. So one of my close relative was had a breakage of ball. Okay, so a treatment like orthopedic treated him. A plate was inserted, and the surgery was successful. Okay, so the treatment as such was successful, but he suffered from some kind of uh, rupture at some point in terms of the screw. Okay? So in order to treat that, and subsequently in order to subside the pain, a painkiller was given to him. Now the doctor was not aware that he is having some kind of ulcer which is affected by painkiller, strong pain. If a strong painkiller is given to the patient, then the ulcer is likely to break, and which can lead to blood loss. Okay? But this the condition of ulcer occurred 15 years back for the patient. And currently, the treatment of this ball was being done. And because this ulcer got unnoticed by the recent orthopedic doctor, he gave a painkiller, and because of which there was a blast of the ulcer, and the blood was not in uncontrolled. The flow of blood was uncontrolled, and finally he lost his life. So, see, keep maintaining an historical data is also of a significant role when someone is being treated. And this in turn brings the role of big data. So, historical data can be very easily maintained through a blockchain structure wherein secured support for maintaining the records could be maintained. However, this prediction regarding what is likely that whether this ulcer will break if say this kind of antibiotic is given to the patient could be done through ML algorithm, and then a decision based on it could be taken for the patient. So, early indication regarding it could have been given by some learning algorithm to the doctor if a record of the patient could have been maintained. And the treatment plan could have been based on those analytics that has been given by the machine. No doubt the doctor is a decision maker. So, but if a doctor gets such hint of this kind through some platform, then that could have really saved the life of the person. Okay, so that is about personalized medicine. Other is predictive analytics, which could anticipates various complications beforehand. So again, you can also consider this predictive analytics, the example that I illustrated as a predictive analytics in terms of predictive analytics, wherein if what are the repercussions of giving an antibiotic, a high dose antibiotic to this patient? Can it lead to any kind of complications? So anticipation of complications beforehand could have resulted into saving of the life of the patient. Other is like if a patient has been admitted, what is how likely a patient is will get admitted again in a 30-day span or a 50-day span. Okay? So we had outbreaks of corona earlier, and we have seen various kind of predictions of various kind of data at that time. So this predictive analytics is actually concerned with various kinds of such unknown outbreaks that could occur in our day-to-day life. Now, apart from this whole analytics related to the patient, even the hospital management task could also be improved by by making use of ML in it. Okay, so operational efficiency is something which can also reduce the burden of the clerks and like administrative staffs that exist within the hospital. So you can proceed, you can always work on using on automating various administrative tasks like billing, documentation, and you can free either the doctor and the nurses and various other um, people who are involved in it, and they can be engaged for treatment of the patient. Okay? uh, Cost reduction and accessibility. So, like if I have an ML algorithm which can diagnose my MRI and can suggest me the possibility, then definitely I'll approach. If it is a case that it's likely that I'm suffering from something, I'll approach a doctor, as I may not go for it. Okay, no doubt. We may consult a doctor for some cases, but still, see, currently the use of social media is social media and this uh, search engine and ChatGPT is increasing enormously. Like if someone is suffering from some disease, he'll directly Google or he'll ask ChatGPT what are the effects of it, what are the situations in which I am suffering from so and so on. So we actually self-diagnose ourselves based on the content that are available. So this in turn is reducing our cost of hospitalization or consultancy with the doctor. So now we'll proceed with an example illustrating the use of ML in few cases. Like I've taken three examples. One is a case study on medical imaging, other is on predictive analytics application, one application of predictive analytics, and again, I have taken some personalized medicine related, or we can say that one another classification related example which is related to diabetes. So I've taken three examples and I'll be illustrating it now here. So now uh, this example is about detection of tumor. Okay? So the problem is we want to detect and classify a brain tumor using machine learning from medical imaging data. Now, if we talk of brain tumor, then there are, broadly speaking, there are three categories. But there is one more metastatic category which is not listed over here. But if it is the case that the originator is from the brain, then in that case, these are the three broad categories, which includes glioma, pituitary, and meningioma. Now, these are the three views that has been listed over here. One is a sagittal, coronal, and axial view. This is something like if you would have heard of orthographic projection. So in first year, we have studied projection. So top view, side view, and front view. So now if we talk of sagittal view is the one in which you move from left to right, face. Like if your face is straight, and if you move from one year to another year, if you take a slice in a direction from left to right, okay, then in that case, that is what is a sagittal view. So this is actually a side view. If you can see, this is sagittal is a side view. Coronal is front to back. So if you take a slice from front to back, okay, then it is a coronal view. An axial view is from top to bottom. So if we take a slice in the middle of your face, like from top to bottom, then in that case you may get an axial view. Okay. Uh, the location of this tumor is basically categorizing them into glioma, pituitary, and meningioma. So you see that there are specific locations at which this tumors are residing. Okay. Now, see, like we want a classification at one. See, there are two possibilities of classification. Whether we want to identify whether the tumor that is existing is cancerous or non-cancerous. Again, if it is cancerous, then whether it is whether we want to know three out of which out of these three is there, whether it is glioma, pituitary, or meningioma. So, if we talk of these three categories, glioma, pituitary, and meningioma, the glioma is the one which is likely, if it is the case, that your deep network or the machine learning model, if it is categorizing the tumor as glioma, then it's likely that it's like more likely to be malignant rather than benign. Okay, so we say that tumor is benign when it's I guess I have kept my presentation. So uh, the glioma cancer is more likely to be malignant rather than benign. The probability that a person is suffering from cancer is high if it has been detected into the category of glioma. Pituitary and meningioma are the one which are um, it's not that if it falls into this category, if a tumor has been detected as into category of pituitary or meningioma is non-cancerous, but it is less likely that it is cancerous. So it's likely that they are benign. Okay, but glioma is expected to have to be more into the category of cancerous rather than non-cancerous. But however, whether it's cancerous or non-cancerous, whether it's benign or malignant, detecting tumor at early stage in either of this category is of utmost importance. uh, uh, see, like even if it is non-cancerous, it may affect your day-to-day activity as well. Like it may, like the cells of your tumor may press few of the cells of your normal brain cells, and which in turn may hinder your day-to-day activities. Okay. So let's say you may suffer from headache because of it. And continuously you may suffer from headache because of the pressing of few of the tissues because of the existence of tumor in your brain, which may be non-cancerous. But if it has been removed, then you may like you may feel relaxed and you may be able to work smoothly. Okay, so removing cancer, like even if if the tumor is cancerous or non-cancerous, removing those tumor is something which may be a preferred thing for a patient. Okay. Now, I stated apart from these three categories, there may be a metastatic category wherein this tumor may be a secondary outcome, like it has not evolved from brain, but the the growth is because of some other reason. So let's say, suppose if someone suffered from breast cancer, and subsequently that no doubt even after removal of the tumor, god knows what is the reason, but after some years, and if you don't do any kind of diagnosis, it is likely that this tumor may arise in some other region of your body, which may be lungs, which may be brain, anywhere. So when the evolution here in this case, let's say suppose if someone is suffering from brain cancer, and this cancer has spread in your body at various places, and the one of the place for spreading may be brain. So a tumor has occurred in the brain because of the occurrence of the tumor in some other part of the body. So this is a secondary tumor. The primary source of this tumor was some other organ, but subsequently it has spread to the brain. So this is a metastatic tumor, which may be which may occur at any place in your brain. So it is also necessary for us to detect such type of tumors as well. Now, given this broad categories of tumor and its scan, if we give, like, if there are a huge number of patients and the doctor is not in a position to spare sufficient time, then in that case a patient may remain unattended. So we need to have some, like, if the doctor is like, he may need to return due to treatment, he might be busy with treatment. It's not that the doctor is not capable. At times the doctor might be capable because he is a very good doctor, he may be engaged in the treatment of the cases. So he may not be in a position to spare time for the analysis of the new patients. So if he could make use of such tools wherein it can, if they make use of some ML based tools, which in turn can, given this X-ray image or MRI of a patient, if the system is in a position to detect whether the patient is suffering from a tumor or not, then this in turn can help us to have an early and accurate detection, which in turn could help us to improve the treatment and the survival of the patient. So we are not replacing a doctor. The doctor is must. Anyhow, currently, even I listed that we can make use of reinforcement learning, wherein a doctor surgery can be performed by a robot rather than a doctor, because he can do a very precise location and removal of various tasks. So there is a scope of removing a doctor even in surgery, if it is a case that a robot has been designed which is very efficient enough to do those surgeries. But as of now, we don't completely, because anyhow this is a machine and machine has to be operated by someone. You cannot keep it running all the times. It is consuming a power, it's consuming various other resources, so they have to be, it has to be provided with those things, and that resource provision is through human intervention only. So, however, but the thing is, the task can be done early and accurately if we make use of the, if we take support of this kind for treatment purpose. Because at times the manual diagnosis may be time consuming and it is subjective. Like, see, this ML algorithms, if you are using ML algorithms, they'll actually give an objective classification, which in turn includes various parameters. What is the size of the so what is the size of the tumor? What is the volume that is contained within it? How much amount of gray matter is existing? What is the black matter or white matter that exists in it? And all those things. So there is a quantitative assessment of all these things available if you are using a learning based approach, which could be subjective if a radiologist is doing these things. They may just view it and say that yes, it is likely, or it is not likely. So they may give a decision which may be confusing. Okay, but if you are using a learning based approach which is giving a very good accurate result, then in that case the response that you would receive from a algorithm of that kind may be very useful for a patient to take the next step, and even for the doctors to take the steps ahead. Okay, now if you want to work on this detection and classification, brain tumor detection and classification, there are several sources of data, out of which one of the very well-known data set is BREDS, which has been continuously updated, and you'll get several huge quantum of data available from BREDS data set. So you can use it for your experimentation and development of model. TCIA is other imaging, cancer imaging archive from which you can get this data. Apart from this, even you can approach some institutions, like you have a civil hospital wherein cancer treatment is carried out for several categories. So if if you're not leaking the privacy of the patient, and if there is someone who could provide the data there from there, then that is also a source of data which could be availed for your experimentation purpose. Now, we want to develop a pipeline which could detect MRI, like which could detect and classify tumor types, okay, from the MRI image. So, what are the possible steps which we can do or we need to perform so as we can perform this classification? This is a simply case study which is illustrating the use of machine learning algorithms for detection and classification of tumors. Now, the way we start is we start with acquiring multi-sequence MRI series. If we talk of Brett's data set, Brett's data set contains T1, T1C, T2, and flare data. Like this multi-sequence MRI comprises of various such categories within it. The one that has been existing in MR, there are several other sequences as well. Okay, but in breadths, these are the four sequences that are existing, and they are sufficient enough to detect tumor in the brain. So T1, T1C, T2, and flare are like, out of all this, again, flare is something which is of utmost importance for tumors. Okay? So you can make use of this series, multi-sequence MRI series for brain tumor detection. So proceeding ahead, after retrieving this information, you will actually pre-process the data so as you can provide it as an input to our model, okay, which in turn requires scaling, normalization, alignment, and all those so as the size fits the input requirement of a network. So once we are done with this, we'll either use some deep network like UNet or CNN, or you may use an ensemble approach so as you can uh, train the network using the label data that is available to us for detection of the tumor type. And once you have trained, you will provide the test data so as you can evaluate them, evaluate the performance of the network. And in order to evaluate the performance, you will make use of various matrices and cross-validation concept for evaluating the performance of the model. Now, so I have listed three main, see, you'll find repetition of few things over here. Okay? Like here in this diagram, polling has been repeated, but you may have, it all depends upon how you want to design your network and what is your requirement in it. But you may find almost in all the CNN networks a repetition of convolution and polling. Okay? Within it. Now, what is the role of convolution? So here comes the fundamental of machine learning. Here now I'm covering the fundamentals of machine learning. These are, I know that CNN, the word convolution neural network would have been known to you long back. Okay, UNet also would have been known to you, but still an understanding of those, because everyone is using it as a black box. If you want to really change upon, if you want to bring a change, you need to have get an understanding of the working of all these components in your network so that you can tweak and twist your network. Okay? So you'll find the repetition of convolution and polling in the in a normal convolution neural network. Now the CNN convolution, the convolution is one of the key term of convolution neural network. Apart from that, pooling is something which is also plays a very significant role in the network that is being designed. Uh, what is what is the role of these layers? Let us understand this thing, and then we'll look into how CNN differs from UNet. What is the purpose of using what can be the purpose of using CNN? What can be the purpose of using UNet? Or can I use a combination of CNN and UNet? Can I use a combination of CNN and any other classification algorithm with CNN? So we'll have a look at all these things in the later slides. But let us proceed with understanding of what is convolution layer and what is role of pooling layer. So this is a very simple explanation of a convolution layer. What is it all about? It's basically concerned with extracting the features from the image. So the features, as we move deeper in the pipeline, at initial level, we extract very abstract features. Okay? Down the line, as we proceed further, by adding this layer, we are actually proceeding towards extracting detailed features from it. Okay, so all these features can be either in terms of texture, or you may consider the edges of the images and all those things. Okay, and combination of all these features that has been extracted can in turn allow you to do the task of classification. Now, when I say that I'm extracting these features, which means that I'm retaining important information and I am discarding those things which are of no use, which in turn reduces the size of the data. Okay, but in order to proceed for the feature extraction process, we make use of some kind of filters. Okay, so here in this diagram, a 3x3 filter is applied on a sub image of the full image, and the sub image size will be same as the size of the filter. What we do is we perform a dot product of the sub image and the filter, and we come out with a feature value out of it. So whatever value that has been represented over here, 434, is a feature value that has been extracted by the filter which has been applied. So this kernel is nothing, this 3x3 kernel is a filter that has been applied on the original image. And if you continue applying this kernel on the complete image, you'll end up with getting a 3x3 feature map. Okay, so the role of the convolution layer is to generate a feature map which is retaining the information. It is basically, the role is to retain those information which in turn will be useful for classification purpose. Now, to give an example which could be easily understood is, let's say, suppose if I want to differentiate my face from some other face. So what are the distinguishing features which can help me to distinguish my face from other face? So the eyes, the distance between the eyes, the shape of my nose, the mouth, the position of the chins, all these things are the distinguishing features of my face. Okay? So if this could be represented in some quantitative form, so as I can use those features for distinguishing it from some other person, then I do not need to retain all the pixel values of the full face. So let's say, suppose if I have a face which the size of the face is 128 by 128, but retaining these features, related to the eyes, the nose, the mouth, the distance of mouth with the eyes, the distance of nose with the mouth, the distance of nose with the eyes, the distance between the two eyes. All this in turn leads to only 14 to 15 features. Let's say I'm just approximating the features. Okay. So if only 14 or 15 features are something which allows me to discriminate my face from some other face, then I should just retain those 14 or 15 features rather than keeping those 128 by 128 size image. So which in turn is like more than 10,000 pixel data. You can just keep 14 data instead of 10,000 data and still you can perform the same task. So the convolution layer is basically concerned with performing this task of extracting the feature. Okay. Now comes the pooling layer. Again, this is also concerned with reduction of the data. Okay. But it's basically confined with uh, spatial feature reduction, which in turn helps us to perform dimensionality reduction. Okay. But it ensures that we preserve the features. Okay. And we preserve the features in such a way that we are in a position to have translation invariance of the feature. Okay. So like uh, if it is a case that my if the eyes shifted from one position to another position, still it's not going to create any impact on my classification task. So if I want to make this um, property available in my classification process, if I want to integrate translation invariance characteristic in the feature that has been extracted, then that property can be is that characteristic is provided by the pooling layer. So one of the most preferred approach which is being used in polling layer, no doubt I have illustrated two mechanisms. One is max polling and other is averaging. But max polling is something which you would have heard of and which has been widely used in terms of feature retention. The characteristic that has been provided by max polling is better as compared to the other polling mechanism, and hence it has been a preferred mechanism being used in the CNN. Okay, so you'll see that 2 cross 2 matrix has been generated from a 4 cross 4 matrix, wherein you take subset submatrix, independent submatrices from the complete matrices, take the max value, which is the max feature uh, from the 4 cells, and place it uh, as a distinctive feature. Okay, so the same has been done for all the 2 cross 2 block that are residing in the original subspace, that feature space that has been created by the con. This is the feature space that has been created by the convolution layer, and this is what the polling layer does. This is the outcome of the polling layer, and we continue doing this unless and until you are satisfied with your requirement. Okay, so what is the expectation on what you require? Based on that, you may continue with the involvement of convolution and pooling within your design process. Sorry. The other concept is of averaging, wherein you take the average of the 4 values. So 12, 20, 8, 12. The average of those 4 values is 13. On similar line, 32 divided by 4 is 8. And there's 34 plus 70, 112, and 100 divided by 4 will lead to 79 and so on. So these are the approaches, but preferred one is max polling. Now, in between these two things, one another concept of regularization. So ReLU is introduced between convolution and pooling. You may not find this explicitly being shown in the networks, but in order to introduce non-linearity in the process, ReLU is being used. Okay? Normally, when you apply a filter, the filters will lead to finding all linear boundaries. Okay? So, if you want to introduce some kind of non-linearity, or if you want to stop that linear flow, then in that case, one can think of using a ReLU function followed by convolution. So if it is the case that a simple ReLU function is max of value comma 0. So if it is the case that the value is greater than the value that is residing over here is greater than 0, you keep the value as it is. And if it is the case that the value is less than 0, then in that case you replace it by 0. This in turn allows you to stop the gradient flow. Like if it is moving in one direction, you are stopping it to move in that direction and abruptly break it and move it in the other direction. Okay, so that is what is the concept of. This is how you can actually introduce non-linearity in your flow. So now, almost all these components that we have seen, convolution, ReLU, and pooling, they are the basic requirement, be it CNN or UNet. You can say UNet is actually a modified architecture of CNN, but with some extra things being introduced within it. So, as I said, in brain tumor detection and classification, we can make use of CNN for classification purpose. We can use UNet for segmentation purpose. So, if you want to have a precise location, if you want to know where in my MRI the tumor is residing, then it's difficult for us to get only by using CNN. So here comes the role of UNet. So UNet can be used for segmentation. You can use it for segmentation purpose, and it's a very well-known architecture being used for segmentation, and it has also been modified by various researchers for that purpose, and has been enhanced for various purposes as well. But the basic architecture, so I am just discussing the basic architectures. You may then proceed towards using these architectures for your purpose. You can also use a combination of CNN and UNet. You can use a combination of CNN and SVM and so on. Like why to use a combination as something yet to be discussed. But so let's say if I have let us have a discussion about the difference between CNN and UNet. So for what purpose one can make use of CNN? So we can make use of CNN for image classification. Broadly speaking, you will be making use of CNN for classification purpose. Or you can make use of CNN for object recognition or pattern detection task. Okay, like let's say, suppose if I have an image of cat and dog, and if I want to classify it or give a label whether a given input image falls into a category of cat or whether it falls into the category of dog, then in that case one can make use of CNN. So this is a very broad categorization or broad classification of an object. So if your task is of this kind, or if your task is only to detect whether a tumor exists or not, then in that case you can definitely make use of CNN. But if you want to locate the tumor, and if you want to basically if you want to explicitly categorize the tumor into the actual three categories that we have identified earlier based on the location, then in that case you need to have a refined model of CNN, which in turn can do the segmentation, locate where this tumor is existing, and based on the location. So I have shown a classification. That classification was actually on the basis of the location. So if it is a pituitary tumor, that is a specific location where this tumor will exist. If it is a glioma, it will exist at specific location. So if you want to have a localization related task, where in this image is it existing, then in that case we can take the help of a unit architecture for performing this task. So segmentation as well as localization task can be easily performed using a unit model, which could be difficult for a CNN only model. Okay, so what we can do is, first of all, if it is a case that we can make use of CNN architecture to extract the features, then don't use any fully connected network for checking whether tumor is existing or not. We can provide the features that has been extracted by CNN to a unit architecture and as a unit model to identify the location where this tumor is existing and what is the category of this tumor. So if we ask unit to perform the task of segmentation and identification of the location where this tumor is existing, then in that case this task could be done in a proper way. Okay, so I stated the whole concept of using CNN. Uh, we cannot perform like there are limitations. As I stated, that we are not doing pixel by pixel task of precisely locating whether this pixel is tumorous or it's non-tumorous and so on. So that is a limitation of CNN, that it actually performs an abstract level task. It performs an abstraction, like feature extraction is concerned with abstracting the inner details to a larger extent. And when we abstract out several those features, then in that case we are not in a position to uh, see when we are providing a translation invariancy in the whole mechanism, it means that it may be existing at any location. We are not bothered about it, but we are concerned whether it exists or not. So that is the only concern of CNN, and that's the reason why we are not in a position to actually identify the actual type of tumor that is existing using CNN. It would be a difficult task for CNN to do it. Right? So the basic architecture, so the four basic components that I have listed, I have already discussed regarding it in detail related to CNN. But what are the distinguishing feature that exist in UNet as compared to CNN? UNet works at pixel level. It's mainly used for semantic segmentation. And the goal of UNet is to classify each and every pixel in the image. So this in turn can allow you to retain the location where this tumor is existing in your original image, and this location is of utmost importance to classify a tumor into a specific category of tumor. Okay, tumor existence and a different categorizing it into its specific type is a two different thing. Okay, which cannot be explicitly performed by CNN, but UNet can perform this task. So what is the output that a unit will generate? It will produce a detailed output map of the same size. So uh, uh, as I said, that CNN generates a feature map. So you'll have one vector, which is a feature map of the whole image. So you are actually eliminating several informations from it. You are not retaining the image size as it is in CNN. But in unit, the output will be of the same size. Output map is of the same size as the input image, with each pixel being assigned some class label, which is ideal for localization tasks. That is what is the main highlighting feature of UNet. And in order to perform this task, the the name UNet is basically given based on the shape of the architecture. It's U in shape. So you have encoder and decoder concept introduced in the U-shape path of the architecture, where encoder is basically considered as a contracting path and decoder is an expansive path. Okay, so you continue with reducing the feature. Contracting path means you reduce the feature. But when you are proceeding towards reducing the feature, at that time, in order to retain the features, we actually pass on the information about those features at every level to the decoder, so that when you are reconstructing the whole image, all the feature maps that has been generated on the path towards contracting the image are retained and can be used for reconstruction of the whole feature map or the image map, output map that has been generated by the decoder. And in order to proceed towards this process, one of the key feature that is introduced in unit is the skip connection. So at every stages, when a feature map is generated by the convolution layer, a skip connection will pass on that information about the features that has been generated to the decoder, so as the decoder can use that information to retrieve back the original image map. Okay. So this is one of the key crucial uh, uh, component of unit, skip connection, which in turn is uh, preserving the fine details for accurate segmentation purpose. Okay? So this is an diagrammatic view of what happens in the CNN model and what exist in an unit model. So you'll see that here you have just a sequence of feature maps being generated. So on the left side is a CNN model, on the right side is a unit model. Okay, the output in case of unit model is a segment which is identified as a tumor in the
4 o'clock, 8 o'clock, 1 o'clock అంటారు. మీరు ఏం పలకరించినా ఆయన 3 బాగా బాగున్నారా అని అయితే పలకరిస్తాడు వెళ్ళంగానే. Participants, mute your mic. ఏమో సార్ ఏంటో ఇంకా మనకు తెలియదు, ప్లాట్ అయితే ఉంది. Ma'am, I have muted.
So on the left side is a CNN model, and on the right side is a unit model, wherein unit is generating an output in the form of segmented image. A segment of tumor has been shown in yellow as an output. In case of CNN, we are giving output in the form of classification, like the feature map has been passed to a fully connected. You'll find that there is a sequence of this pooling and convolution layer being integrated, and at the end the feature map is passed to a fully connected network, which in turn classifies the output for us. So this is the gist of what we have covered for CNN and unit. So if we talk in terms of the various aspects of comparison for CNN and unit, the purpose of CNN is to classify and detect, and you can use unit for segmentation purpose as it works at pixel level. The output will be a class level or a bounding box. In case of unit, you'll find a mask, a pixel-wise mask of the tumor. If we talk in terms of localization, it's basically coarse and it's approximate. But in case of unit, you'll get a precise
ઘરે
detail.
જઈને શાંતિથી આવો તો વળી તો ત્રીજું સેશન ચાલવાનું જ છે. આ પીના બીના થયા છે બદલીને.
The training,
લઈને આવજો ને હવે.
the training data that is being used is image level labels. In case of unit, you have pixel level annotated mask. So this is where the difference exists in terms of the input that is being provided to CNN unit. The architecture, if we talk about the architecture being used in CNN and unit, CNN is only encoder only architecture. In unit, you use encoder, decoder, and skip connection. You can specifically use it for tumor existence, like CNN can be used for tumor, whether tumor exists or not, and one can think of using unit for detecting exact tumor shape and location, which in turn helps us to categorize it precisely towards the three categories that we have seen. Okay, so we have covered several components, like we have seen the
Ma'am, unmute yourself.
એકચ્યુઅલી તમે મ્યુટ કરો ને ત્યારે મને ખબર નથી રહેતી, કારણ કે મેં મારી આખી સ્ક્રીન શેર કરેલી હોય છે ને.
ના એકચ્યુઅલી કેવું છે કે પાર્ટિસિપન્ટને મ્યુટ કરવા જઉં છું ને તો કદાચ એમાં થઈ જતું. હું જોઈ લઉં છું મેડમ. હા,
એટલે પાર્ટિસિપન્ટ્સ બોલું એટલે એ લોકોના તો મ્યુટેડ જ હોય ને બાય ડિફોલ્ટ, તો અનમ્યુટ કેમ?
અમુકને ક્વેશ્ચન કે એવું રેઝ થાય ને ત્યારે હું ખાલી અનમ્યુટ કરું છું એટલે.
પણ એ લોકોએ ક્વેશ્ચન તો કઈ રેસ કર્યા નથી, કર્યા છે રેસ?
ના, એટલે એ વચ્ચે કોઈકનો અવાજ આવ્યો ને ત્યારે મને એવું લાગ્યું એટલા માટે મેં અનમ્યુટ કર્યું.
ઓકે ફાઇન. અને મારે સ્ટોપ કરવાનો હોય ને ત્યારે પણ મને કહેજો, એટલે હું થોડું પછી સમરાઇઝ કરી દઈશ એ પ્રમાણે.
ઓકે, નો પ્રોબ્લેમ મેમ.
So we have up till 5:30. Okay, so
it's 5. It's up to 5.
Okay, it's up to 5 only. Okay.
Hmm.
So we have seen various parts of the pipeline, wherein we start with the input image, we normalize the image, like given in MRI image, we normalize those image, we apply some model on it. So we have seen the kind of model that we can apply for MRI. Followed by it, once you have designed a model and you have trained that model using the training data, you like the proportion of data is normally the preferred proportion is 70-30 or 60-40. This is the amount of data that is like 60 for training or 70 for training and 30 for testing purpose. So once you have trained your model using the labeled data, you'll be testing you'll be feeding the test data, and based on the outcome of the results that has been received for the test data, you then decide upon the performance of the network. Okay? So the machine learning model that has been evaluated should be evaluated using various performance parameters. Now, if we talk of CNN, so we have seen two architectures. One is CNN and one is UNet. So what are the parameters that one should use for evaluating the performance of the model that has been designed? So I have listed few of them. These are specifically meant for CNN evaluation. And apart from this, there are few other parameters which we can use for, which we should use for UNet. So let us have a discussion on this. So the matrices that you can use is accuracy, precision, recall, specificity, F1 score. I hope all these terms, because since you have 1 week FDP, all these terminologies would have been covered. But still, for this example, I'll illustrate the significance of each and every component. Now, accuracy, as the term states, it's true positive plus true negative, means all the correctly categorized information is in the numerator, and the complete set of data that has been used. Yeah, this when we are talking about determining the values for these parameters, it is for it is evaluated for the test data that has been given as an input. Okay, we are not concerned about the training accuracy. We are concerned about the testing accuracy. So if I have used, let's say, suppose if I have 1,000 data, and if I'm using 70% of the data for training purpose, it means that 700 data has been used for training purpose. So now when I'm evaluating my system, I'll be evaluating the performance on 300 data. So if I'm evaluating the accuracy of the test data, which is 300, then TP plus TN plus FE plus FN should be 300. And whatever true positive and true negative values that I have received will be in my numerator. Okay. So this basically metric gives us overall correctness of the predictions. It may be misleading at some time, and when it is when it will when one can consider or when it is likely to have a misleading result is when the data is imbalanced. So let's say if I have a data, like if my model has been trained with a data wherein I am using like almost 800 to 900 data which is non-cancerous. So normal brain MRI has been given for the training, and only 100 data were containing tumors in it. So this is highly imbalanced data. I'm having 90% of the data which is non-cancerous and only 10% which is either cancerous or tumorous. Okay? So if I'm training my network with this data, and if I'm using only accuracy as one of my parameter for evaluating a system of this kind, then in that case, this is not a preferred metric. So in those cases, one should opt for using various other matrices as well. And you should also just don't rely on a model of this kind. If you have an imbalanced data, you need to work on uh, um, some mechanisms which can help us to resolve these imbalances in the data. So you can also offer, so the few of the cases wherein you can, like, if you have heard of SMOT is one of the technique which can help you to resolve this imbalanced data set availability. Apart from that, so if you want to confine on using only deep learning model, it's okay with using this kind of approach. But if it is a case that if you want to work really on some innovative approach, then you can make use of some reinforcement learning, because reinforcement learning is something which helps the system to learn from the environment. So if the system is not in a position to take the decision based on what information is available from with it, then it can uh, mm, reinforce the system. Like, given this test data, if it is not in a position to learn, it will through some rewarding mechanism, it can improve the system so as it can give better response subsequently for this kind of data, if it has not encountered this kind of data previously. So why you are having only 100 data? Because, and it may be a case that this 100 data may not contain an information which has to be taken into consideration for a test data that has been given as an input, in spite of the fact that the test data is having a tumor. But this kind of tumor was not existing in the earlier 100 data that has been used for training purpose. So this in turn can lead to misclassification of the uh, results that has been generated. So solely relying on accuracy is something which is questionable, and this in turn expects, if it is imbalanced, it expects you to have some novelty in the approach that you are taking. But like if you received a good accuracy, in spite of the fact that the data is imbalanced, you should also offer using some other measures as well. So the other measures or the metrics that you can use is precision, which basically is a fraction of predicted tumors that are true. Like if you see the numerator and the denominator, TP and TP plus FP. Now, if it is the case, see, if you have an unbalanced data, then in that case you proceed towards using such measures like precisions, and you can make you can take support of basically F1 score rather than, because F1 score is again derived from precision and recall. So instead of relying on accuracy, if you rely more on F1 score, what is the value that you get, and if it is good enough, then in that case it's fine, that in spite of the fact that it's an imbalanced data, it is giving good results. It means that my network is good enough to categorize all category. It is generic enough to categorize the various categories of, right? So if you talk of precision, precision is basically the ratio of TP upon TP plus false positive. Now see, we want to basically reduce the impact of false positive. And if we want to reduce the impact of false positive, if the precision is high, it means that you are like the false positive impact is less, which in turn indicates that you are not giving treatment to someone who is not suffering from tumor. So this is something which is like, see, you if someone is not suffering from diabetes, and if you say that you are suffering from diabetes, or if someone is not having cancer, and if you say that you are suffering from cancer, this may actually create a hype in that person. So he may start taking medications in spite of that he is not required to do. So he will be in like there will be unnecessary anxiety in the person because of this high false positives. So the precision in turn will, if high precision is there, in that case you are actually avoiding this kind of scenarios. However, recall is something which is really very important element, which is basically the ratio of TP upon TP plus false negative. Okay, so if you are saying that you are not suffering from cancer in spite of the fact that you are suffering from cancer, so that is very very dangerous thing. That like if a patient is suffering from cancer, and if doctors say that you are not suffering from cancer, and let's say this happens in the first stage of cancer, that the system has detected, the system is supposed to detect, and the system has not detected, and this in turn is preventing the doctor to give medications, required medications early to the patient, and which in turn have a repercussion of uh, increased staging of the cancer. So a person may be in a second stage or third stage of the cancer because of not being detected in the first stage. Okay, so recall should be very high. If recall is not up to the mark, then in that case the system is not acceptable, because you are not detecting a person who is actually suffering from the disease, and which in turn will delay the medication requirement to the patient, and which may create a very huge impact on the patient survival. Okay, so this the relevance of recall as compared to precision is even much more. But if in case of imbalance, like as I stated, F1 score is something which is using a combination of recall and precision. So as rather than trusting more on accuracy, relying more on F1 score is something which is of utmost importance. Okay. Uh, Specificity is okay. So these are the parameters which one can use for CNN. Apart from this, uh, so I'll take it much bit faster so that we can complete it in time limit. So apart from the parameters like recall and precisions, which were highlighted earlier, and specificity and accuracy, which can be used for unit as well, the important parameters that the matrices that one should use in unit model is dissimilarity coefficient, which is um, the measure of overlap, uh, Jaccard, dissimilarity, HD, and MSD. These are the preferred matrices which one should use for evaluating the performance of the model they are using if they are integrating unit within their implementation. Okay. They basically, these are this measures to this dice and Jaccard similarity measures are to large extent measuring the overlapping of the actual segment and the predicted segment. Okay, so based on the overlapping region, this score is being calculated. The score is basically calculating this overlap region. Okay. uh, Hertz of distance is basically measuring the boundary closeness. So you may have a boundary being generated by the original tumor, and you will have a boundary being generated by the predicted tumor. What is the distance in the boundary between the two is something which is measured by Hertz of distance. So how much amount of translation is being created could be measured using this distance measure. Okay, and mean surface distance is basically the average distance between the predicted and ground truth boundaries. Like, so this was a clear cut distance, like a Euclidean distance sort of distance being measured between uh, the boundaries of both the segments. But here, in the case of mean surface distance, it's actually calculating the average distance between the predicted and the truth. So apart from this, like, one can make use of a combination of the of CNN SVM. Like as I said, that you can use a ensembling of unit and CNN. You can use a like for classification tasks, instead of using a fully connected network, we can also make use of support vector machine, which is also very good and a robust mechanism for classification. Now, why I suggest a combination of CNN and SVM is, if I use SVM directly on the original image, then it may take days and days. If you're having a normal machine for implementation of SVM on Brett's data set, like your system may crash, or you may like need to run the machine for n number of days to receive the response. Okay. uh, the support vector machine is basically concerned with finding an optimal separating plane, and this optimal separating plane is found using the label data. So if I have 700 images with me with um, like 10,000 data for each and every image within it, I'm telling less, but the MRI image size will be much more than 10,000. So what SVM will be doing is will be creating a 10,000 dimensional space to find a separating hyperplane between the objects that exist in those space, and finding a separating hyperplane in a 10,000 dimensional space. And just taking an example that the image sizes, the number of pixels that are residing in an MRI image, one single MRI image is 10,000. Then finding a separating hyperplane in a 10,000 dimensional space is a really very time consuming task. Instead, if this 10,000 dimensional space could be reduced into a feature map which is of size 10 or 15, and then if I am to find a separating hyperplane for this 10 dimension or a 20 dimension, it's practically possible for a support vector machine to perform this task on a normal machine. So this in turn will, the use of CNN in this case could lead to reduction in the computational requirement. Okay. So as I said that it's a confined, it actually reduces the size. So if it reduces, this pooling layer is basically reducing the spatial features, then this in turn will also reduce the computational requirement that are required subsequently. Okay, so if I'm using a support vector machine for a 10 dimensional data, my computational requirement will be much less as compared to if I'm using a 10,000 dimension data. And this then this will be a very robust approach towards performing classification of the feature map that has been created by it. So what support vector machine does is it takes some n-dimensional data. Let's say if I have a feature, if I have a p-dimensional data available with me, then as an input, it takes those p-dimensional data and it finds a separating hyperplane, which in turn can allow me to classify the objects that are given as an input. So that is one of the features. So what I said earlier was like it finds a separating hyperplane. But what if there is a non-linearity that is existing in the data? So every time it's not necessary that I'll be in a position to find a plane. Okay? So the data may be such that, like the one that has been projected in the slide, is showing that there is no such a separating hyperplane which can separate the blue and the red dots. So kernel tricks comes into picture over here, which in turn allows you to move a lower dimensional space data to a higher dimensional space, find a separating hyperplane in a higher dimensional space, and then again project it so that you can find a separating hyperplane. I was actually, I wanted to discuss few other examples of using this technique of SVM on some data. I have live implementations with me. I'll share the slides, but I have live implementation. I haven't applied SVM on a breast data set because, as I said, that the dimension of the data is too large. If I run SVM on my machine, I'll not be able to get the results in 2 or 3 days. Even running it on for 2 or 3 days, I'll not be able to get the results. So I took a very simple example of prediction of diabetes using SVM, and the parameters of the features that has been used for it is of this category. And I have a live example of running this code on my machine. I can just demonstrate and execute this code, and then we'll just conclude the session. So again, I'm using a PIMA data set, which is available freely with these parameters. I hope it's taking some time because the data is being loaded. I have an execution on another machine, but fine. Let's let it. Okay, so it's executed. So I've executed this code and I'm having a results corresponding to it. So I discussed various, so these are the parameters on which a prediction regarding whether a person is diabetic or not is being done. Okay, so given this data, these are the test data which has been given as an input, and see that there was 768. The size of the data set was this is available on PMAS. The size is 768 with 9 parameters, and when we tested this code on the test data, like 20, 30, 70 was the data size that has been hopefully used for training purpose, and the whole result for the test data, like around 156 data has been used for testing 154 data. So the support is basically projecting the number of data that has been used. So this is the precision recall F1 score and support that has been generated as an outcome of execution of this implementation using support vector machine. Okay, the accuracy is not so good in spite, like again if we look at the various results, we'll be able to see that for non-diabetic person the result is much is not so good as compared to diabetic person. For diabetic the result is not so good as non-diabetic person. This in turn is stating that this model is not so good, and the reason for it being not good is because of the can be several, like you may need to tweak the network, or the amount of data that is available is much less, or the imbalances that exist in the data. So like you'll see that the support is projecting the number of data that has been used for non-diabetic and diabetic. For diabetic 100, non-diabetic 100, and 54 is the quantity of data that has been used for in the diabetic category. So since there is an imbalance in the data, this in turn is reflected in the results that has been generated. So the outcome is actually shown in terms of accuracy. This is a confusion matrix which is showing that how many has been truly how many true positive, true negative, false positive, false negative. The heat map that has been generated shows the relevance of each and every parameters that has been used. So this is basically saying that the glucose is having an, like say other than um, glucose, none of them is having a higher value. Okay, so the last field is the outcome. In the outcome field, the value 49 is maximum, which in turn is stating that glucose is impacting a lot for a diabetic person. But other than that, there are several other impactful cases like this 54%. So pregnancy, if it is associated with age, like if someone with who is above 40 is pregnant, it's likely that he or she could have diabetes, or she could suffer from diabetes. So these heat maps are actually very good in making various kind of conclusions for determining the pregnancy occurrence, sorry, diabetes occurrence in a patient. So this is one example. I have another example, but let's wind up. Mm, as of now, let's, because I guess the next speaker is so I shall conclude my presentation now. And I have few other case study wherein XGBoost is used for prediction if what how likely that if some patient has been admitted will be readmitted in 30 days. So uh, I have a good execution of XGBoost as well, but I'll share the slides with you. I hope this content would be fruitful to all of you, and I'll conclude my session from this slide. Okay.
Thank you, ma'am, and for sharing your time in your busy schedule, actually.
Actually, I'm
And
busy.
yes, but it was really a nice session. And please share the PPT. It will be very helpful to the participants also.
Sure, I'll share the PPT.
Thank you. Thank you very much, ma'am.
You're welcome. Okay.
Uh,
I'm leaving now. Is that
yes,
okay?
ma'am. Sure, sure. Participants, our next expert is